It is my pleasure to introduce Dr. Derek Long. Now, Derek is a colleague and a really good friend of mine, and we're going to be talking about machine vision today. For those who don't know much about machine vision, in very simplistic terms, it's about creating code to allow robots to use images or webcams in their activities. Now, what that means is when we give an image to a robot or a computer looking at that image to act on behalf of the robot, we need to look at the image and know exactly what to look for and tell the robot how to look for it. See, robots aren't very smart. They're quite dumb. And so we need a code that tells them to look for something. For example, if it was a robot that was looking for the color red, I'd have to tell it, what does red actually mean in computer language? And it would be a mixture of red, green, and blue pixels, which would break down even further to ones and zeros. So the algorithm will tell it exactly what series of ones and zeros to look for. And so that's how we tell computers or robots to see. And so Derek is going to be talking about a lot of projects he's done. A little bit about Derek. Derek is a lead researcher in vision at the Centre of Agricultural Engineering, which is part of the University of Southern Queensland. And he's worked on projects with drones, with tractors, with smartphones. And essentially his job is to make machine vision algorithms that can monitor machines and essentially take out labor-intensive tasks. He also enjoys teaching machine vision, and so him and I have teamed up to do a few machine vision workshops. And so today we're going to look at how can robots see. We've got a special guest. His name is Dr. Derek Long, and he's joining us. He's actually a postdoctorate researcher at the Centre of Agricultural Engineering at the University of Southern Queensland. Derek specialises in machine vision. He's a bit of an expert in anything robotics and anything in ag. His goal is to be part of the story of how technologies like machine vision and automation can help us to continue to feed and clothe the world in the coming years. So I'm really excited to talk to Derek. I've had a lot to do with him over the few years that I've known him, both as a researcher and a bit of a friend who we've both got such a passion for with technology. So yeah, thank you so much for joining us, Derek.
Thank you.
Awesome. Yeah, so I'll jump into the very first question. And the first question I have for you is just introduce yourself to everyone and maybe talk a little bit about what you do and how does machine vision fit in it.
Sure. I introduce myself as just a big fan of computers. I didn't grow up with a background in agriculture. I grew up with a love for maths and a love for technology and a love for computers. And as I went through university, I did a degree in engineering, and I wanted to find a place where I could use that to help the world. And the opportunity came up, the path came up that I could apply these skills in agriculture to help our farmers and help our growers and people running livestock to keep evolving and keep sustaining themselves into the years to come. And it's been a really great place for me to apply my passions, and I really love it.
Yeah, awesome. And I think it's interesting when you get into ag, doing engineering in ag, you realize how hard the natural environment is. Hey, so it's a big problem to solve, would you say? Like
it's well, when using machine vision and cameras, it's a lot different from being in a laboratory. If someone's looking at something under a microscope, we can have exactly the lighting conditions we want. But when we're out on the farm, there's different kinds of cloud cover, different things change with the seasons. It's a lot less controlled and, yeah, a lot more difficult.
Yeah. No, cool. And I suppose it kind of brings you to the next question. You kind of mentioned where you kind of started with this tech, but when was the first time, in general, you got into robotics, and what did you build maybe, or what was your first system you made? And yeah, how did you fit machine vision into that?
My first go at using machine vision was on drones. So I first tried to play around with getting it to follow me around or follow an object I was carrying. And then when I got to take it out into the field, I was looking at irrigation, so tracking our water use. It's very useful on a farm to monitor variability and how plants can vary and how the chemicals and water that we apply vary. So this was in surface irrigation water floods from one side of the field to the other, and that can be very variable, and it's useful to know where water's being used more and where it isn't. I have here the drone I built to
Wow.
put a thermal camera on. There's lots of wires and such. I did have to put it together myself, buying a frame and then the electronics that I wanted to use. But just building it was a lot of fun, and doing some lovely field testing to check it worked, racing it for a few laps. But that was kind of where I got to start, and it's led on from there to lots of different places where we can have cameras, not just drones.
Yeah. Wow. Cool. So yeah, it started with drones, but obviously the same tech's used everywhere. So yeah, no, that's really cool. And how old were you when you started in drones and robotics and vision?
My passion for computers goes back well into my school years, but channeling it into this application is something that only happened during my degree. Everyone's story is different. Personally, I didn't quite know where I was going to end up when I studied. I just knew I had the passion for the medium, for the technology, for computers, and so it came about as I entered university and I could explore the options in front of me of where I could work.
Yeah. No, that's really cool. Awesome. And I suppose, it brings me to the next one is, out of all the tech that you've used, and maybe even just sensing and things that you've done in robotics, where is machine vision kind of particularly useful to use? Like, what applications and what does it enable you to do with robots?
Well, the biggest thing that many of you out there will see them in the future is self-driving cars. There is excuse me, so many sectors of society where machine vision is going to be used in manufacturing to help our plants work better, in transport to help our vehicles drive smoother and reduce accidents, and of course, in other places. And it's my job now to help bring that technology to agriculture. So that we are moving really quickly towards this world of automation, and where computers that use vision and machine learning take on larger and larger roles in all of our tech.
Mm. And I suppose with computers getting so fast, vision is more capable of recognizing things, doing things faster. So it's more appropriate to use, I suppose.
Well, certainly, a decade or so ago, it was very impressive to have 4 cores in a processor in one's computer, but now some people's even phones have 8 cores in them. So it's come a lot in 10 years, and I can't even picture where we'll be in another 10.
What are some of the coolest projects you've worked on from any research or from any robotics?
I've really enjoyed getting around to many of the different parts that make up our agriculture sector. So it started with looking at cotton irrigation, which was a lot of fun, and using different types of cameras is really fun. So using thermal cameras, or using shortwave infrared cameras or near infrared cameras, things outside the normal visible spectrum that you and I see. But looking at smartphones and how they can be used, these tiny little powerful computers in our pocket, and cameras on tractors as well. So one of the most fun things was getting to go and do field work in the US on one of John Deere's test farms as part of my work with them, to use both sides of the hemisphere. So do data collection in our summer, and then go and do it in their summer. Being able to travel and see what goes on in the world is really, really cool.
And especially with John Deere, I mean, they're the leaders in the world for what they do. So yeah, did you find out anything interesting working with them or seeing what they did? Or
it was really interesting to see how they work with other universities as well. So I got to see one of the largest agricultural universities in the US, which is only an hour away from where I was based with them in Iowa. And it was a great experience to take in how other countries do things, but nothing specific, just a great experience that I can draw from going forward.
Yeah. And could you just mention to everyone? I know there's a few projects you've done, so I'll just pick them out. But could you mention the one you did with insects and you made an app for?
So that's one in progress. I mentioned the powerful computers in our pockets. What we're currently trying to use those for is to help farmers keep track of pests in fields better. So currently they have some very small insects called whitefly or cotton aphids that sit on the underside of cotton leaves. They can be only a millimetre or so long, so quite small, and counting them is a very repetitive or not very attractive job. So one of the many ways I mentioned that machine vision can come in and help here is designing an app to count that for them. So they can just take a quick picture of the leaf and then they walk on to the next leaf and the app does the counting for them. That's something we're working on at the moment and trialing with cotton agronomists.
Yeah, and that would save them hundreds of hours of time easily, hey?
Well, it's about saving them time. It is about making them it quicker, and it also does all the logging for them. But it also can help make them more consistent because, say, if an agronomist had a helper or some students helping him, people have different levels of experience, different levels of eyesight. So it also can make them more consistent. There's actually quite a few trickle-on benefits that perhaps you don't think of at first when you bring technology in like this.
Yeah. Yeah, wow. No, that's really cool. Okay. And in terms of machine vision particularly, and we've touched on it both in a collaborative session as well as you mentioned at the start, but just a few thoughts. I'd like to hear how you would see machine vision changing everyday people's lives in the next 5-10 years or whatever.
Yeah, I think there'll be a lot more in the way of home automation, how we gain access to buildings. Really, the really big one will be self-driving cars when they become widely available and that becomes frequently used. And there'll be lots of new things that we haven't even thought of yet that simply weren't practical to do. I mentioned the whitefly before. That's counting those out and taking down the exact number was simply not practical for someone to do. But now we can do it with technology. So some of the big things will be things we haven't even thought of yet because we just wouldn't do it.
Yeah, 100%. I mean, even there's things like, I know they're bringing out cameras that can detect when people are on their phones or they're not wearing a seatbelt. And obviously that's going to catch a lot of people out. They probably don't like it, but the technology is there to make everything safer. And if we didn't have cameras to capture those images and we didn't have people like yourself building algorithms to actually make those images meaningful, then that's where that technology comes in, isn't it? So,
yeah, policing is another area. You're quite right. Analysing crime scenes could be another. I'm aware, I think police have started in cases using a drone to quickly get up and take in a view of a scene so that they can take it down and quickly clear the scene if it's necessary to get traffic back on, restore traffic flow. So there's throughout our fire services, hunting bushfires, there's lots and lots of things, and that even ties into another form of camera I haven't talked about yet, being satellites. I think people are working on machine vision algorithms to automatically process the wealth of satellite imagery that we take in to find things like fires or other points of interest that go on in the world.
Oh wow,
so that's another one.
Yeah, that's a whole nother aspect of vision. Wow, oh, that's cool, awesome. Specifically for machine vision, and I know you've said you've fallen into agriculture, but what other things I suppose has developing knowledge in machine vision allowed you to do? Whether it was one of it's to be a researcher that's looking at things that have never been solved in the world, which I think in itself is pretty incredible. But yeah, what is being able to learn technology and use it being able to do for you personally or professionally?
There are many different kinds of skills that I've picked up along the way. The machine vision might be the unique thing I bring to my job, but I've certainly learned a lot more than I otherwise would have about programming. I've learned a lot about education in trying to share this thing I love, and a lot about communication. I've learned a lot about app development, funnily enough. So I need to be able to prototype what I'm making on the smartphone as I work. So diving into the basics of making an app and then putting my unique programs and algorithms onto that.
Wow.
There would be more. That's just some of what I've picked up on the way.
Yeah. Wow. That's actually, I didn't know that about you. So that's really cool to, yeah, there's so many disciplines to just knowing technology. Hey, you never just do one thing. So,
No, and then another big one, machine learning, which is somewhat quite related to machine vision, and also a huge thing that will be part of our society in the coming years.
yeah. Yeah. Wow. Cool. The next question. So for kids who want to start in this area of machine vision or robotics in general or programming, let's say, where would you suggest they start and how would you suggest they learn?
Excuse me. I think that there is so much power in the free online tools and tutorials that we have available on the internet, be it from YouTube or some other site. There's nothing stopping any of you from grabbing a laptop or a computer and starting to make something very simple with the tutorials that are on the internet. Some of them, a lot of publicly accessible information rivals what I've learned throughout school or even going into university. That's very powerful, and it's at the fingertips of anybody with an internet connection and a computer. So to get started, using search engines, Google could even help you find the place to start. For whatever your field of interest is, be it programming or something different.
Yeah. So you think just firstly search, because that's the thing, the internet is almost endless now. So just search for something and try something out for free and just get into it quickly. Is that what you're kind of saying?
Yeah. Well, with any luck, how the big search engines like Google are designed is that the things that do work and the things that people recommend are the things that come to the top. So hopefully some of those great and really useful resources are the ones that you'll see up first if you try to look for it on the internet.
Yeah. And then obviously there's the tool that you've developed. Could you just talk a little bit about the tool? Because I mean, the best thing is by using that tool, kids can they get a good grasp of machine vision very quickly, and it's built by someone who is actually an expert. So yeah, could you just chat about what that tool is and how it works?
I really wanted some of you all to give this kind of programming a go without having to write code. So I did make a simple little program that allows you to kind of make building blocks or put together functions that could allow you to, say, find a weed on a patch of grass or find a colored object you're carrying, identify a person even. There's it's a very useful little educational tool that I've been able to use in some schools close to me, and hopefully with the power of the internet we'll be able to reach a bit wider with it as well. So that's machine vision tool it's currently called, and it's a little pet project of mine.
Yeah, I think it's incredible. I think easy to use, and it doesn't. The thing that I love about it too is you've done a great job of giving kids the usability. They can jump in and play with it almost instantly, but you don't take away the real engineering behind it, which is the part I love. I don't know, because you haven't taken it out, so it's not actually machine vision. It's very, very much still quite authentic to engineering. So,
well, it's important to understand the basics behind it all. It's important to understand how a computer interprets color. It's important to understand the information it takes to send to a screen so that my face can be shown in the detail it is, and what goes into a pixel of color. So that kind of is where we start. And then if you identify the numbers per se that represent the color red, we can start to look for that, and then we can start to group that together or find a red object. So it really does build from the basics, and it is a lot of fun, especially when kids take the task of making themselves look as silly as they can. It's one of our favorites.
Or as scary, depending what filters they put on it. Yeah. No, awesome. And the very last thing, Derek, I suppose for anyone who wants to reach out and get in contact with you, where can they reach you, and what could potentially be a touch point there?
Well, excuse me. for people who happen to be nearby to USQ, there'd be the chance to come and experience this directly, either by getting in touch and visiting USQ, or having us come to the school, where we're happy to do that. And I suppose emailing me would be the first point of contact there, and I can maybe we can display that, or I'll provide it separate to this presentation.
Yep.
In an online sense, for those of you who are further away, there's potential opportunity to experience that through integrated STEM. So that's the way that you could have a play with that online, and that's it's part of a wider range of technologies and projects that you can experience there.
And I think and for everyone out there, Derek's been working very hard at developing this tool to be as good as it is. So I mean, I think it's an experience I can say with 100% guarantee it's an experience that most people wouldn't get, is to be able to play with machine vision as authentically as it is. So yeah, massive credit to your development skills, Derek. I think it's incredible. And yeah, hopefully a lot of kids get into it. So.
Well, hopefully it inspires something, be it machine vision or a different form of programming, or a different part of computers that piques your interest. If you give it a go, that's a big part of finding what you like, is just giving everything a go.
Awesome. Well, I might wrap up there, but I just want to say a massive thank you, Derek, for being a part of this, and really sharing your passion, and also being so actively involved in developing something that kids can literally go home and use. So yeah, massive thank you, and yeah, thanks for being part of it. Derek, again, a huge thank you for being part of this session. I can't express enough just how valuable having someone like you be available to us to chat to and explore technology with. For everyone who wants to follow Derek or see what he gets up to, we've got some links here. There's one link that goes to the Facebook page, and one link that goes to the university website for the Center of Agricultural Engineering. Those two places are great to see Derek's work and to see other researchers' work at USQ. We do some incredible things there, and it's always great to check that out. You've also got the email of Derek to touch base if you need. So the next session we're going to do with Derek is to actually showcase machine vision. So in this session, Derek will have his machine vision tool that he's developed and that we use in our workshops of machine vision. And he'll be walking you through a few key things about the fundamentals of machine vision and developing algorithms on the spot for you to see what actually happens inside that type of algorithm. It's going to be a huge amount of fun, and it's going to be something that's completely unique to anything you've probably ever seen before. So we'll catch you then.